If you're interested in developing a career as a data scientist, one of the best things that you can do is start talking to and getting to know other data scientists. And one of the best ways to actually do that is getting along to things like different conferences and events where you get to see different data scientists speak about the different projects that they do, what it's actually like in the real world, some of the challenges they faced, and some of the latest solutions that are coming along to try and solve these types of problems. It's all good sometimes jumping on Google and asking a few questions. The problem is sometimes is that if you're looking somewhere like Google, there's a lot more old information than there is sort of new current information. And so that's one of the traps that you can bump into. So a lot of the information can be quite skewed because of that. And so actually getting to know some people in the real world and asking them why do you do things a certain way is a really good way to kind of expand your horizons and get a better idea of what everything's about. So I'm really excited to have had the opportunity to present at and listen to some amazing speakers at an R Data Science conference hosted by Auckland University. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. So I've just finished uploading and summarizing 20 great talks, which cover 5 key themes. So first up is the importance and value of open source software for data science. So this was a fantastic presentation given by Allaire, who's the founder of RStudio. Next up, we have accessible data science. And this is basically talking about various new tools that are being developed so that people who don't know how to code can get involved in data science, as well as different teaching techniques and strategies for teaching data science to more people, starting from like high school students. Thirdly, we have a whole bunch of amazing data visualization techniques, some very innovative techniques being used, as well as some tips for data storytelling. So some great sessions there. Fourthly, we've got professional infrastructure. Now, what we're basically talking about here is when you start to use data science within an organization, within a team, and you start pushing things into production, and when you are starting to maintain these things, there's a whole bunch of, I guess, best practices that you want to follow, which will massively reduce the number of headaches you have, make sure your work is like more scalable, make sure it's easier to collaborate, all those kind of things. So that's what I'm talking about in professional infrastructure, and there's a whole bunch of really great talks on that. And then finally, there was a really great presentation showing some cool new tools in R for processing billions of records on a single computer. So you could actually process billions of records on, say, a laptop, which is pretty amazing stuff. So definitely check out those presentations. Now, this was a full day event, so there's around 8 hours of presentations or so. Over the next 60 minutes, I'm going to attempt to summarize all of them so that you can get an overview of what each of these presentations are in a little bit more detail than this little list here. Obviously, this is not going to cover everything that these talks went over. These are kind of the key points that stood out to me, that I found interesting, and that I think will hopefully be helpful to you as well. So, without further ado, let's get started. So I was really excited to have got the chance to meet Allaire, who is the founder of RStudio. RStudio has made some amazing tools for working with R. All of the training that I do is very much based around a lot of the developments produced by RStudio. Things such as the Tidyverse, R Markdown, Shiny, all come out from the RStudio development teams and have been open sourced for everybody to use. Now, this is some of the key things that JJ actually started to talk about in his presentation. So JJ was a software tool developer. He's developed some amazing tools like CodeFusion. CodeFusion was actually the first programming language that I used when I first left university. It's a web development language which at the time was around about probably half the code of other server-side scripting languages available. Things like PHP and ASP, which were pretty popular at the time. CodeFusion just got a lot of those things done a lot faster, and it was probably the most unique one of those programming languages available due to the fact that everything was kind of tag-based, just like HTML was. And so everything was sort of in line without having to stick things into scripting tags, which made it really efficient, which was really kind of cool. Now, JJ actually went on to sell that company to Macromedia, which then went on to be sold to Adobe, where they now maintain the CodeFusion product. Now, one of the things that JJ pointed out, which I found really interesting, while working on these different tools, he found it really rewarding, but he found that as a startup, the sort of end goal of it was to effectively sell it to another organization. And in that process, you would effectively end up losing that product. And this was something that was extremely disappointing to him. So having gone through and developing a number of products quite successfully, when he went off to start RStudio, he really wanted to do something different. And he started RStudio as an open source project. And there's some really important reasons for this. So the first one being reproducibility. Now, reproducibility is something that you'll hear data scientists talk about all of the time, but it's something which is really, really important. If somebody conducts an experiment, we need to be able to test if that experiment was done properly. There's been lots of times that there have been mistakes in scientific research, and that has led on to some quite drastic effects. So being able to reproduce those results is a really key thing. Now, part of the problem with proprietary software is basically that everybody needs that software. Everybody needs to be able to get a license to that software in order to be able to run that experiment if an experiment is written in that particular programming language. And this is why an open source programming language like R or say Python is really important to the furtherment of scientific research. So there's a little case study on that there, which he talks about. This is the other thing that JJ talked about in his talk. So where does software go when it dies? So we've seen over the last few years organizations like Argo who have purchased, say, open source software like MySQL and have progressively made it more and more difficult to use. Now, fortunately, because the software was open source in the first place, then basically the community forked a copy of MySQL and continued on its development as MariaDB. And so the software was able to survive even though it was taken over by a larger organization more interested in making proprietary software. Open source software also means that we can have greater participation in the development of the software and the use of it as well. And this ties also into accessibility, making sure that it is something widely available to a lot of people without having the cost overhead of having to buy something. He also goes on to talk about things like, is open source a viable way to build tools, and really how to fund these projects, because a lot of times these projects, they're done for free. A lot of speakers and presenters, they have done an amazing amount of work, basically for the kind of passion of it, trying to solve their own problems. But this is difficult sometimes because without having a specific budget to build these tools which further development of things, maybe we aren't always getting the best quality tools we can. So finding a way to be able to fund these endeavors is a really important question to try and figure out. And so the way that organizations like RStudio work is that they have an open source tool that is accessible to everyone. So any individual who wants to come along and do some research, do some work, can pick up these tools, download them, start using them without any restrictions at all. And the only place where they actually charge is for enterprise products. Now, enterprises which have millions and millions of dollars to basically spend on these kinds of things, and are often spending a lot more money actually with different other vendors which are charging a lot more money, have various requirements such as sort of managing users, administration, security controls, all these kind of things, which are not so relevant if you're, say, a small team or if you're like an individual researcher or something like that. And so RStudio charges enterprises for their products, for enterprise products, which then funds the development of open source tools. And I thought this was a really nice model, actually. Okay, so the next talk was from Jacqueline Tran, who practices data science for sports performance. So she gave a really interesting presentation here. It was interesting to see some of the technology that was used back in 1927 in order to capture data. These control gates here are actually magnetic sensors back in 1927. So that's actually, I was really quite impressed with that, actually. It was interesting to hear some of the challenges that they face, such as sports analytics today is, the problem used to be that we didn't have enough data. Now we have too much data. And I would say that this is probably not just true of sports science, but also many, many other areas of science as well, that we have so much data, but getting down to the relevant key points is really the key things that we need to focus on. Another great talk here was by Jayne Ihaka, and she was basically helping to build chatbots with R. So this is conversation analytics. So here you can see a bit of her workflow where they're basically classifying different questions asked by customers so they can figure out the best way to try and respond to them. So some really interesting things there. How successful is this program? Whenever we deploy something, we need to find a way to measure how well that's actually doing so that we can continuously refine it, find out what's working, what's not, and basically go off and make it better. So there's a whole bunch of different approaches for doing this, like getting ratings and confidence scores, sentiment analysis, and various bits and pieces that can kind of be done in an automated way. But at the end of the day, for this project and for a lot of other projects as well, is really getting a human to go over it and see that it makes sense. So an important aspect in there to think about when you're working on your projects is to get some human feedback, because sometimes computers aren't really always as smart as we think they are. Okay, so this presentation on data test presented by Harel Lustiger. So basically the gist of this talk here is that whenever we are developing things, we want to try and separate them out. So he talks about how a lot of times you have an analytics module. So you basically have a piece of analysis which is very much dependent on sort of fixed database schema. And whenever that, say, database changes or something like that, then a lot of things can break and you can have this ripple effect. So by effectively breaking up and compartmentalizing your code into different bits and creating layers, you can effectively reduce some of these dependencies and have your analysis continue to work even when the data changes. So generally really good practices to try and follow. So another great presentation here from Chris Wild, who is working on this product called iNZight with a bunch of, with a whole team of some really clever, great individuals who are working on this pretty amazing product. And basically what this is a graphical editor for making visualizations based on R. So if you're not familiar with code, which I actually talk about how most people in the world, only about 0.5% of people in the world are actually capable of coding. And so making something which is more accessible to people is definitely useful and very important. I think another thing as well, if you're coming from, say, an Excel background and you've used things like VBA, I think you really appreciate things like the macro recorder, because it allows you to record a few steps and then figure out exactly what the syntax is in order to be able to create those results. And if you're not coding very often, or you're just starting out, those things are really, really, really helpful, so that you can figure out what those are. And once you get more familiar with the code, then you just start to write it yourself, just because it just becomes so familiar and it just becomes faster to type it. And there's some other benefits as well. But having tools like this massively lower the learning curve for tools such as R. Now, I've reviewed a number of these kind of tools which have been developed in the past. Things like a Squizzy are fantastic products. This tool that I saw in this presentation today, iNZight, is probably one of the best, most sophisticated tools I've seen. It's very comprehensive. It's got a large number of visualizations with parameters. It even covers stuff like network data, which if you've seen some of my other videos and stuff, you realize that I'm quite a big fan of. So a really, really powerful tool. All the code which is generated for you, and this is another thing which is really key. So one of the key differences between, say, a tool like this and a tool such as Power BI and Tableau is that this will give you the code at the end of it, which you can then use to either learn how to code or generate visualizations which don't have this license costs associated with sharing it, such as you do with tools like Tableau and Power BI. So I think those are, some really good benefits there. Now, these aren't directly comparable tools, and maybe in another video I'll try and give a better explanation of the difference between something like Shiny and Power BI and Tableau, because it's very easy to try and compare these things, and there are some crossovers and similarities, but they're also not exactly the same kind of tool either. So maybe I'll talk about that another time. But this tool, absolutely fantastic. It's really great. Okay, we had another really good presentation here on the visualizing sleep in pregnancy with R. And so this was given by Victoria King, who is a PhD candidate at the University of Auckland. And she talked about some really interesting things here. Again, when you try and visualize too much data and you don't really think about how you visualize it, then you can end up with visualizations which are effectively meaningless. So what you really want to try and do is reorganize that data in such a way where you're going to get more clarity and sense about what's actually going on with it. A few other interesting things here that she mentioned that I thought are good for people to know. Occasionally you would see kind of weird spikes in the data and everything like that. Now, I've seen plenty of times, and I've even made this mistake myself in the past, where you think, oh, what is this big spike in the data? This must be something really strange or weird going on here. Let's go find out what this is. And then you basically find out something like a sensor got disconnected or something like that. And more often than not, like if you see something really strange in the data, there's usually a much more sensible explanation to it, like, the data feed got cut, than it really being some strange outlier. So something really useful to keep in mind when you are working in things like data science. Okay, here we had another really great talk on reproducible science. So there we have the word again, reproducible science, reproducible research. And so Caleb Moss, who works with Dragonfly, He talks about how they really geek out about all this kind of stuff, and basically how they use a lot of kind of DevOps kind of practices. So they've developed some of their own tools for continuous integration, which do automatic builds and automatically run chunks of code to produce outputs and different things like that when you push your changes to GitHub. So pretty cool. It basically just means that everything gets out in a much more automated kind of way. So when you get to a certain level, you definitely want to be able to be looking into these things to get some efficiency gains. Okay, so this is a fantastic presentation by Anthony Southworth, who talks about R in production. And I love this, how he says here, yes, really, because one of the things is that people tend to say all the time is that R is not suitable for production. That's why we use Python and all that kind of stuff like that instead. And this is interesting because R can be used in production, and there are some times when that kind of really makes sense to do, right? So what Anthony talks about here is the benefit of having R in production is speed. Getting from your analysis to a final product, if you're not having to rewrite it in another language, which is supposedly production ready, then you can get things out a lot faster. So if you have a team who is largely working in R already, if you have workflows which are have a high amount of, say, statistical research or exploratory data analysis and different things like that, then it can make sense to be using a tool like R, which is very fast for those types of workflows, and then being able to take those and shift them into production really quickly. So he goes on to talk about things like, well, you know, there are a few things that you need to think about when you do these kind of things. You can't just take a piece of code and just push it out there and expect it to work everywhere. So this is something that you really need to try and think about, is that just because something runs on your computer doesn't mean it's going to run on somebody else's computer, doesn't mean it's going to run on a production computer, because each of those computers might have different operating systems, different operating system versions, different software versions installed on all of these different machines. And each of those things is going to could potentially break your code on in that environment. So some of the tools that they use to manage this include things like Git, libraries such as Packrat, and Docker. So Docker is one of the things that's used by quite a few data scientists, and I guess the easiest way of explaining it is that, you know, it captures all those things that I just talked about, the bits of the operating system versions, software versions, and it packages it up into a container, and then you basically ship that entire container to anywhere that the code needs to run. And so it runs off, everything that runs off the container rather than that computer, which might have a whole bunch of things which are different about it. So a very useful tool. Okay, so here's a great talk here by my friend John Graves, which talks about how to be more productive as a data scientist. Now, John actually got this idea from another one of our friends, Owen Flanagan, who also has some presentations in here. And he talks about how by using different tools, you can really get some productivity gains. So, you know, this is an R conference, and so everybody is generally familiar with R. Maybe you have your different tools that you're familiar with, whether it be Python or Excel or whatever it is. But different tools definitely have benefits for different types of applications. So a lot of data scientists will be familiar with maybe working with something like SQL, because that's the language that you use to extract stuff from databases. you probably want to be able to do a little bit of command line. Those kind of things are useful as well. Being able to use spreadsheets properly, text editors, regular expressions is always something pretty useful for being able to manipulate, extract, and search for different types of text. So different things, different skills that are worth to look at and think about. It's worth to know kind of what these kind of things are. Now, if you're just getting started, don't get too overwhelmed about learning every single thing there is. That's not really the kind of point of this. The point is to be open-minded about the different solutions that are available so that you can kind of tap into them and learn the things that are basically taking you a lot of time. John talks about a few other things that help people to learn and why people for now are still better at learning than machines for a lot of different types of things. So he talks about here, focused attention, active engagement, error correction, and consolidation. So, a lot of good little points there for learning things. So another great presentation here by Harel Lustiger, who talks about the craft of data and storytelling. So this is actually a really interesting presentation. And he talks about things like, so this is a mischievous data storytelling, and how really a lot of people use data storytelling as a way to kind of almost mislead people in a way. The reason why this is misleading is because the graphs aren't scaled kind of proportionately. And so, they're trying to show that this one is much worse than this one here because it's so much bigger. Whereas the difference maybe not as much as it's made out to be. And so we just have to be careful and aware of these kinds of things because a lot of times I never tend to trust any statistics kind of quoted in the media or anything like that because they tend to be a bit misleading. Okay, he talks about the importance of killing your assumptions and that one data visualization has multiple narratives. Each room is composed of different assumptions and aspirations. And so, we're always dealing with different people with different agendas and different ideas, different assumptions, everything like that. And we just need to be mindful of that when we are doing things like data storytelling. Okay, so listen, measure, refine, basically talk to people, get the feedback, everything like that. He's got a few interesting things in here. So meaningful interaction, so fewer drop downs and tabs. I thought this was an interesting thing to point out because I tend to use a lot of drop downs and tabs. And so I just wanted to draw this one out actually, because when you are data storytelling, you do tend to have like much more of a kind of narrative. And so you want to kind of lead people from kind of how you started to how you came to some sort of conclusion. And you want to show people how you got there. Now, the reason why I tend to have like a lot of drop downs and tabs is because when I'm building a dashboard, a lot of times I'm not building it for the purpose of data storytelling. I'm using it as a tool where I've got every request kind of on hand. So if a stakeholder is asking for another view or something like that, basically it takes me 2 seconds to pull it up because I've already built it in as a parameter to the system that I'm working on. So, kind of different ways of building dashboards, but just something to think about there. Highly parameterized, everything on hand kind of dashboard versus a data storytelling dashboard. So some interesting points. Okay, here was another really good talk, 30 maps in 30 days, the case for publishing first drafts. So this was really interesting. So Emma Witz, she talks about how she took up this challenge to do all of these data visualizations. And this was a really good point. I mean, she did some pretty amazing stuff for such a short span of time. But I think that kind of pressure kind of almost gives you this kind of motivation and drive to get stuff out quickly. And that can be quite a valuable thing. One, because you're kind of getting more feedback to, you kind of have to you kind of lose the ego or lose the fear of something not being good enough. And I know I kind of suffer from this myself. I'm sure there's lots of things that I don't kind of put out there that just kind of sit in some archive on my computer somewhere because I don't really want to put it out because it's just too embarrassingly incomplete or something. So, but she talks about the value of getting those things out. So maps can be art. So this was a really cool visualization that you put together using some satellite imagery here and using some algorithms and stuff to like highlight this river. Anyway, just a really cool visualization and cool presentation overall in different ways that we can use maps. Okay, another cool presentation by Aaron Schiff on how to make your own ggplot2 themes. Now, this is interesting because, to be honest, like personally, I tend to use like all the defaults as much as possible. It means that whenever I walk into an organization, like even if it's a different organization, then there's zero setup to do, like everything's just there. So if you can't use defaults, it can reduce a lot of work. So I'm all into that. But a lot of times I know you walk into an organization and they have specific requirements. Some people have really want things to look a certain way. And if everything is supposed to look that way, then it really makes sense to set up some sort of theme. Because then everything will always look that way just by importing this thing. Without having to set these things up like every single time. So if you have those requirements, this can be a massive time saver. So he gives like an example here. He's implemented a theme, so it's got like a fixed set of colors, and you can get very kind of granular in the control so that everything kind of fits pixel perfect into this report and everything like that. So some really interesting techniques in there, and if you want, just like any of the presentations, you can go out and check out the whole thing in this playlist that I've put together. Okay, so here was another presentation by Thomas Lumley, who's another professor at the University of Auckland. And here he's also talking about maps, and this time he's actually talking about some of the problems with using maps. And that is basically that when you overlay data onto a map, certain areas of a map are bigger than others. And this kind of gives them disproportionate visual value over areas which can be much smaller. So some of the problems are sometimes that the very lowly populated areas have very big landmass, and some of the very highly densely populated areas have very small landmass. And these things just don't get represented very well when we just lay colors on a map like this. So here is one solution for that. So here we have the United States, where each state is split up into a square. So now we don't have the visual distortion of having states which are different sizes. The size has been made uniform, and so we can tell much easier what's really represented by simply looking at the colors. So very interesting and useful visualization there. Now, interestingly, he went on to talk about how, well, this works for countries like the States because they are kind of squarish, right? But they don't really work so well for countries like New Zealand. So the solution for that is basically, instead of using squares, right, is to use some alternative shape like a hexagon. So here he's used a hexagon shapes for effectively doing the same effect. And I don't know, I just thought that this was kind of very innovative problem solving and some interesting use cases and things to think about there. Okay, this presentation by Anna Marie Ferguson, she's talking about 5 ways to make LearnR even better. So for those of you who don't know, LearnR is an interesting platform where instead of installing R on everybody's computer, you can just kind of set up exercises in the cloud, and you can teach lectures and get people to interact with things, right? Write a little bit of code and get these examples to run. And so this is nice for teaching situations, basically because there's very minimal setup on the user's part to get things going. You can keep things nice and uniform. And so what she's going over here, and to give you a little bit more context as well, so she teaches statistics to high school students. So I think she's doing some great work here, and some great work to make it more engaging and more interesting. And by using colorful, fun exercises, which just bring a little bit more life to things rather than just a bunch of code and statistics, which may be fun to geeky people like me and other data scientists, but maybe not necessarily to everyone. So there you go. So here was another great presentation on animating statistical theory. Again, we are looking at ways to make teaching more engaging, more interesting, and just to help things sink in a little better. So this is using animations and interesting visuals to kind of convey which things that you don't always get by just looking at a static image. Now, I've got a static image here, so you can't really see the whole thing, but just seeing the things like having principal component analysis explained through these animations where things are kind of pivoting around and everything like that was just really interesting to see, actually, in quite a nice way to represent it. Okay, and then of course a presentation from yours truly. And so here I'm talking about effectively, this is kind of my journey from how I went to an Excel user to an R user, and how I think I'm trying to reach more people with things like R, because I think that R has not been maybe that accessible. And I think this was quite a focus of actually quite a few of the presenters in the talk today, is how do we make these things easier for people? Because a lot of people aren't necessarily programmers, right? And some of the things can get extremely technical. So how do you make it easier? And so one of the things that I've always talked about kind of in my courses to, I guess, differentiate them, is that my courses, well, they were built for Excel users. Well, some of my courses anyway, built for Excel users using kind of the newer R standards, and they're focused very much on the things that Excel users do as opposed to things that R users do. So, and that just kind of makes it more relevant. So, things like if statements, VLOOKUPs, pivot tables, the things that you would do maybe in Excel on a daily basis, you want to figure out, well, can R do those things, and can R actually make my life better doing those things? Because even if R does all this other stuff, but it doesn't handle your kind of day-to-day first, then, I think that makes it very difficult for people to make that transition if they've got day-to-day work to get done. So what I really try and do is try and show people how R actually makes that better. Okay. So again, like I just had this little slide in here, and here I was talking about how I was like teaching like robotics and coding to my kids and stuff. And I thought I'd kind of drop this in here to talk about this as well, because I just like mentioned in the kind of previous presentations how we do have tools like LearnR. And I have been thinking about if I should be trying to incorporate these kind of tools into some of the work that maybe I'm doing. Now, one of the things with the courses that I run is that part of the idea and purpose of it is to get people in a corporate environment who are usually really pressed for time, and they want to get a job done, and they want to get it done fast. There's usually not a lot of time to go have the luxury to go off and study things and kind of work through practice exercises and all this kind of thing. So part of the idea of the training that I put together is to get people to give people examples that would be easy enough to apply to their own work in the shortest time possible. And that's kind of really the focus and attention of that. And so because of that, I haven't got people to do exercises, right? And I know some people haven't liked that, but I haven't gotten people to do exercises within the course so much itself, because I just want them to apply it. Now, in a student situation, that's a little bit different, because it's not like they have some job to go do or anything like that. So you do end up with these kind of simulated projects. And so, when I'm like working with my kids, there's kind of puzzles, and there's preset puzzles that they kind of work through to accomplish some objective in order to learn some sort of skill. And so there's kind of different approaches. And so what I wanted to say is that different people have different needs at different times. And so, it's not like there's one best training or one training which is much, much better than another one or anything like that. It's different training for different people, different times, different contexts. So again, here, one of the things I talked about is that basically, data science is kind of complicated, right? Because it includes, basically these areas which are entire professions on their own. And then having to try and know all of them, it can be a pretty hard thing to do. But, starting with what you know, and then starting to talk to other people in other fields and seeing how you can help them out, can be really beneficial for everyone. So I started with more of a computer science kind of background, with some domain knowledge as well, because I spent a lot of time working kind of very closely with businesses, and then kind of getting to know the stats guys and helping them to code, because statisticians don't traditionally know how to code, or a lot of them don't know how to code, or even if they do know how to code, they don't necessarily know the software development practices which will allow them to be more productive in code. Okay, so I talk about really how we need to try and do a better job of educating people about what data science really is, because what you see in the media and what most people think about things is a bit misleading, and this can lead to expectations which don't really match reality, right? So this was kind of the key point that I wanted people to go away with for my talk, is to reach more people, we have to be relevant and understandable to them. Okay, so another great talk here on our cloud collaborative environment for visualization and data analysis. Now, basically what this is, and I've kind of talked about this a few times already, is that when you start to get multiple people working together, right? When you start off, it's just you quite often. But to do anything significant, you really need to start working with a team. Of course, then you have stakeholders, and basically there's all kinds of different people involved in a project. And sending code around, sending things to like lots of different people can be a difficult thing to do. Like doing things over email is not usually the best idea. And then, as I talked about earlier, we have environment issues. And so having a single common environment. Now, I already talked about things like Docker before, but what I haven't talked about is things like, things like our cloud and other products like RStudio server, which effectively allow you to have an environment that you put in the cloud and then give multiple people access to it. So it's like everybody's using a single computer, but from wherever they are. And this makes working together much easier because everything is kind of updated. Everybody's running the same version of everything all the time, and this is really helpful. Okay, so this was another talk from Tom Elliott, who's also from the iNZight team, and this was a really interesting topic because the iNZight tool, like I mentioned, it was a really impressive tool for what it can do with our graphics and visualizations all through a GUI basically. So it was a pretty sophisticated piece of work. And so this was sort of the behind the scenes of how they built that and the techniques they used to build that. And so he was starting to go over things like object-oriented programming and how they implement object-oriented programming in R, which is not something usually a lot of people think about. I know that personally I tend not to use object-oriented programming in R because it's probably more relevant to package development than analysis work. But a lot of people don't even realize that it's there. So just to know that it is something quite useful to know. Okay, this was a really great presentation here. So this here was talking about this new package called DiskFrame. Now, what does DiskFrame do? So one of the things one of the limitations traditionally with things like R and Pandas for Python is that they are constrained by memory or RAM. So as soon as you exceed your memory, then you run out of space. You can't do anything anymore. The thing basically breaks down and dies. Now, a lot of times in a lot of my videos I talked about, it's like, well, actually, there's quite a bit of data you can process, right? So with 16 gigs of RAM, you can probably process 5 to 10 gigabytes, 5 to 10 million records of data on a computer. And for a lot of people, that's like quite a bit. And I've talked about how, definitely for a sample or something like that, you can start to do these kind of things. But sometimes you do want to be able to maybe process larger data sets. So here we're going from, say, tens of millions up to billions of records. And to be able to do that, you effectively need to be able to store things outside of memory. Now, it is possible to use things like databases for these kind of things, but one of the downsides of databases is basically that it's an additional installation. It's like a whole other application, and databases are traditionally not very fast or optimized for analytics type processes. So it tends to be much easier and faster to work with a data frame, especially if there's kind of no really additional installations or that you need to get approval for, and like additional dependencies if you're sharing stuff around and all that sort of thing. So there have been a number of solutions. So I've talked about some of these things before. So you've got things like Spark and Dask. So Dask is Python's distributed data frame. And but the other thing that it does as well, which I haven't really talked about, is the fact that it also allows you to create data frames which are larger than memory. So even if you only have a single computer, you can still benefit from Dask. And it seems to run pretty well. Now, Spark really gets its benefit from being a distributed system. So, this is where you are loading data not across one computer, but multiple computers. So it's interesting here. He's got here that, this is like free but slow. I would say that it kind of depends on a few things. A Spark data frame can be run in memory or on disk, or like some combination. So if it was all in memory, I would expect Spark to be like further over this side. If it was a disk-based Spark cluster, I guess it would be a bit slower. And one of the things with data that I've kind of talked about a few times before is effectively that part of the slowest part of data is kind of loading it and transferring it around, especially across networks and different things like that. So if you can minimize that, which I guess you would typically have to do if you were taking a single data set and distributing it across a Spark cluster, which is multiple computers which talk to each other over like maybe a gigabyte Ethernet cable or something. Then there's going to be some overhead splitting that up. There's going to be some overhead transferring it and all that sort of thing. So there can be some benefits here of working with something like Dask or this amazing new package called disk.frame. So interestingly, disk.frame actually turned out to run faster than Dask. I mean, this was just some initial tests. But it was interesting to see that, and perhaps that's to do with like all the technologies that it's built on top of. I've talked a lot about things like data.table in the past, how it's really, really well built, and one of the fastest in-memory data frames around at the moment. So disk.frame is kind of built on top of that and basically strings a bunch of those together and uses a bunch of other techniques and everything like that for splitting up the data across disk. But very clever. And if you have data sets which are too big to fit in memory, these can be some great solutions for you. Okay, and here's a talk from my friend Owen Flanagan. What are people tweeting about Donald Trump? So this talk here is interesting actually. Owen's done some really interesting tweet analysis, but probably what's more interesting actually is kind of the infrastructure and everything that he set up to do this. So it's almost more of an infrastructure talk than it is about Twitter analysis. And so he's got this set up here where he is using things like AWS RDS, which is basically in AWS database. So we've talked about this a few times before. So me, Owen, and some of our data science friends about different data storage solutions that he could use. Also, he has here AWS EC2, which is basically a compute service, which he runs Ubuntu, and he runs R and Shiny on top of. And he goes on to a whole bunch of other things, and I've got like a much more detailed talk from him where he talks about like all the libraries and packages that he uses Docker and everything as well, and just some really cool stuff that he's put together. So yeah, at some point I hope to have like another chat with Owen where maybe we can share like a bit more of his work with you, and yeah, get to learn how he strings these kind of architectures together and some of the rationale behind them as well. Would be really pretty interesting actually. Okay, so that is it. If you want to see any of these presentations in a bit more detail, then I have recorded all of them. Unfortunately, for a number of the presentations, I seem to be getting some radio interference or something, and so the mics sound really crackly, and so the audio quality is really not what I would like it to be. But the presentations are there if you would like to check them out. So please do. If you like this video, then please consider liking and subscribing. Anyway, I will leave you to check out any of these other videos that you find interesting. And as mentioned before, one of the best ways of developing a career in data science and developing your skill as a data science is getting to know and finding other people which are working on things which are kind of relevant to you. So then you can pretty much follow their lead. There's a lot of amazing information in a lot of these presentations. It's not like you have to go off and learn all of them and know everything. It's all about understanding and having the right context, and having these presentations is almost more about getting context. It's some of the things that I really try and do is to tell you not just you should learn something, but more so here's why you might want to learn something, and if you are in a certain situation, because these days there's too much information to learn. This is all pretty complicated stuff, so learning what is relevant to you is really key. All right, thanks for that. Again, yeah, if you like this video, like and subscribe. Otherwise, I will talk to you later.